Look at views. So views, as I mentioned earlier, right, it allows us to name queries that we might have found to be useful. Right? It might be that we're selecting something, and if you remember, we can nest queries. Right? We can nest select statements already inside of a either because we want to reuse it in an in clause, right, in the where clause, right, or we want to put it as part of a virtual table in a from clause, right. And it might be that this query is actually very useful. We want to reuse it over and over, but typically, so one might say, well, why don't you just create a table for it, right? Just create a table and populate it with the data, right? Why recreate this on the fly every time? It's very expensive. Right? Especially if you have a query that is being used by some other query. Now you have two queries running, right? And one depends on the other. And there's a lot of calculation that goes along, having to search and iterate to find all those records that meet that criteria. It'd be nice if we could just have that stored permanently, right? And the data can be just retrieved from this permanent storage. It would be much faster instead of having to recalculate over and over. But oftentimes views are useful when you've gone through the normalization process, right? You've broken up these huge tables into the constituents, right? You've eliminated redundancy, right? You don't have any inconsistency, and you feel good. You met first normal form, second, third normal form, right? Your schema is beautiful. You don't want to touch it. But somebody comes along and says, "Oh man, I want to do these queries where I want to do the retrieve information about certain students." And I have to join with this table, join it with that other table, or join it with some other table. It's very inconvenient. I have to do like 3-4 different joins, to recreate my query. And I know you're dealing with normalization, yada yada yada, but it's very inconvenient for me. Right? So wouldn't it be nice if I had a table that's just going, I can just see what it is instead of having this. So that's exactly where views come in, right? Views allow you to create these queries, right? These tables, these virtual tables that are very convenient to consume, right? But without actually creating the table, because if you went along and actually created that table, you would be breaking the normalization, right? If you took a lot of effort at breaking out the sections and the students and the enrollments. You broke it out in the courses, but now the registrar says, well, I would like to have a table for my weekly report where I can have the students along with the courses, along with the sections, along with their grades, right? I like to have this table so that I can generate my report every week. It says, well, you should resist the temptation to actually create a table and create the redundancy that you work so hard at removing. Yes. So instead, what you do is that you create a view. You create a view, and to create a view you can create a view by giving a name and then associate it with the select statement that you want to associate it with, right? And this creates something that looks like a table, but is not actually a table, right? It looks like a table when you click on it. It has all the columns, right, and all the records. It looks like a table, but instead it's being executed on the fly, right? And you can treat it just like any other table. So, for instance, here you have we're creating a current product list that's going to select the product ID, the product name, and then where discontinuous falls. It might be that you have a long list of products that you've been in business for years, and throughout the years, many products have become discontinued, right? So now you have where only a small fraction of what you actually sell, right, is valid. You have a long history of stuff that have become discontinued over time, right? So it'd be very convenient to just out of the 10,000 products that I have, I like to only look at my 1,000 products that actually haven't been discontinued. My active products would be very convenient. So I could create a current product by doing a query. So only I want to see the ones that are false, that were discontinued as false, right? And now I can treat it as a table. I can now run reports off of it, right? I can run statistics, analysis, and treat it just like any other table. Notice that here we're doing to select all the records from current product list. Current product list. Notice that it's being treated as if it were a table, but it's not, right? It's almost like a nested query. It's as if I took that select statement and I pasted it in here with parentheses. You see that? So any nested query is a candidate to become a view, right? Especially if you're going to use it over and over in different places, that's a perfect candidate to give it a name and then use it, right, as if it were a table. Or you could have views nested inside of views, right? And you can have them arbitrarily complex, right? So you have here, we're creating another view that has a select statement, and then in that select statement, notice that we have another nested select statement in there, right? Inside of the where clause, right? Where we're running this nested with one another. Yes?
So the view going to be updated automatically?
Right, we'll talk about update in a minute. If the update is trivial, yes. Right? If the update is not trivial, no. Because a view could retrieve data from multiple tables. If it's from one table, and the record that you're updating and the field that you're updating can very easily be mapped to the original record and the original field, then yes, you can update it. But instead, if that field is maybe an aggregate, say, right, where it's a sum of many different values, then you would not know which other records from where it was aggregated from, what you should do. Make sense? So we'll see examples of that in a minute. So here we have another query where we are doing a subquery, or you have a view within a view. Right? Once you create a view, you can very easily create other views in terms of previous views. Right? Where here, for instance, we're saying we're creating the view category sales for 1997, which is written in terms of the select statements, whose from clause is another view. See that? Right. So again, you could treat it as if it were just as a regular table. Right. Actually, we've been using this technique throughout for the last couple of weeks already. Right. We've been writing things such as QXYZ is equal to a select statement, meaning whatever that select statement returns, I am storing it in Q65 over here. Yes. Now formally, we can say now that to implement that we use create view of Q65 as and then the select statement. Right. So it means don't execute it right now. Instead, postpone this execution until later, right, when I refer you either in the from clause or where clause or select clause, and then run the query. You can reuse it. Here we are implementing one query in terms of Q65, right? Now, when previously we saw nested queries, right? We wrote a select statement inside of another select statement, right? Like this one, your select statement within an outer select statement. Usually, another name for these that you can refer to is you can say that this is sometimes these are called inline views, right? You could have used a view and named it, but here you're kind of like writing it out. Right? So it's like a view, but it's being used inline, right, and written out specifically and formally inside of the outer select statement. Sometimes we refer to this, those databases that support this kind of feature. Sometimes they call these views, or the feature of allowing you to create these views, they call them external schemas. Meaning you have a schema, the actual schema, right, the one you normalized, right, the one you broke it out into big tables, you broke it out into multiple tables. That is your schema. But you might want to provide an alternative or an external schema, a schema for consumers, the folks who are consuming the data, right, that don't know how to join or be very inconvenienced, right, and you provide a view, right, into the data that is just for convenience purposes, maybe for running reports, right, or for running the statistical analysis. Yes.
The conceptual schema here is the UML, right?
Yes. So, for instance, if they're in the dean's office, they might say, I don't want to have to join all these things, right? I want to have the student information, and some information lives in the department, some information lives in the student table, some information lives in the enrollment, right? I'd like to have this schema, right, that has the numbers of courses that I've passed, the number of courses that I failed by GPA, and these are all pieces of information that are spread out over a whole bunch of tables. But it would be a schema that's convenient from the dean's office point of view, right? Or from the registrars, or from HR, or different departments might want different reports, daily, weekly, monthly, right? And so the way you would do this is that you would not create a table for this. Instead, you would create a view, right, that has a select statement that queries and merges data from across 3 different tables into one view, for making it convenient for whoever is using your database, right? Updating. So updating can be challenging. Sometimes it could be ambiguous what you want me to do. All right. Now the updates that are trivial, meaning if my view is selecting from a single table, then it's easy to calculate. If my original table A, right, has 1,000 records, and I create a view on A that these are all the products, and these are just only a subset of the products that are active, right? And so there is an unambiguous mapping, a one-to-one mapping of each one of these records against the original record that was retrieved from, right? And this one from that one over there. If that's true, then the database will say, sure, if you update a record here, if you update a record or field or change the price or whatever on this view, I need to go back to the original record from where I got it from and actually make the update. And that's okay, right? There's no ambiguity. But sometimes there is ambiguity, right? Because it could be that actually one record here is actually the joining of 2 tables, right? Where I have some records here and maybe one value here, maybe is the it would be A.A plus B.B. Now I'm adding 2 values. Yes. Now it makes no sense that I can update that field, because updating that field would mean that I would have to somehow update a record in A and a record in B, right? There would be no one-to-one relationship between the 2, right? Also, what would it mean if I remove a record from here? If I remove this record, what does that mean? Does that mean that I go back and remove this record from here? Is that what it is? Then, if it's a one-to-one mapping, the database won't mind, right? There's no ambiguity. But if there is ambiguity, then the database will stop. It says, no, I don't know what to do, right? It'll stop, right? Especially if you have grouping. Some of these fields might be grouping of multiple records, right? The average of these values is represented in a single record, in a single value, right? So modifying this would mean that I would have to go back, right, and update hundreds of records that were used to calculate that one field. Again, updating is non-trivial. So let's consider a couple of things, like deleting from a view. Say you have this view that grabs information from a student and department, right? And so you have Joe is enrolled in art, Sue in math, and Alice in computer science, right? So what would it mean if I delete Sue and math, right? If I want to remove Sue and math, what does that mean? How should the database interpret that? What do you mean? Do you mean that the student no longer exists and they left the university? Is that what you're saying? Or that the math department doesn't exist anymore? Is that what you mean? Or are you saying that they both exist, but they're no longer related to one another, right? That Sue is no longer enrolled in the math department. Is that what you're saying? So now it's ambiguous what you mean by removing a record from here, right? So we would not allow the database to make decisions for us, right? Instead, again, we would use cascades and things like that, on cascade deletes and whatnot, right? So it's not intuitive, right? So same thing here, inserting. When you insert Joe drama, so Joe is enrolled in the art department, but then you insert a record into a view that says that Joe is now in drama. What does that mean? Does that mean that Joe is no longer enrolled in art? Instead, they're enrolled in drama? Or does it mean that they're enrolled in both of them? Right? What does that mean? Right? Again, the intent is ambiguous. Right? So we would typically not allow databases to do these kinds of things. Right? That's where store procedures come in, right? And says, oh, you're inserting into this view? Ooh, I have a function for that. And in the function, I can specify exactly what I want to happen. Right? I want to say, oh, you're inserting Joe into drama. My interpretation is that I insert another record into the enrollment table that says that Joe is also now enrolled in drama. That's my interpretation, and I encode it. Or if I delete Joe from art, it doesn't mean that the art department goes away or that the student goes away. It's that the enrollment record goes away. Yes? Right. So stored procedures will allow us to do that. Also, materialized views. So materialized views is a really cool concept that keeps the idea of views, but makes them better, right? So views in general are somewhat expensive, right? Because especially if I'm using a view in a from clause and whatnot, it could be expensive having to calculate these select statements over and over, right? It'd be nice if these select statements would hang around for a while, right? Because if I'm using it so many times, it'd be nice if they were physically existing in the file system instead of having to recalculate them every single time. Yes? So materialized views is a concept of having a view, and you get the hit, the performance hit only the first time, right? And what you do is that instead of just doing select statement, you create a brand new table, an actual table, and you insert all the results that's in there. Next time around, when you do a query on that select statement, you use the materialized view, the table, right? The table, because now the data has been already calculated. I don't have to recalculate it. Yes, right? The problem is what? Usually, if you have a normal view will always have the very latest query. Yes, because if you run the query, it always goes back to the original tables and rebuilds the result sets. Yes. Now materialized views are not. Materialized views will, at best, be an old copy of some old query. Yes? So you have to make sure that if any changes happens in the original tables, if I insert new records, if I remove old records, or update any fields in those records, right, that would affect the view, I have to recalculate the materialized view. Make sense? So I have to support all this. Usually this is not for free, right? You would have a whole bunch of stored procedures and triggers that would listen to the original view, the original tables, right? If somebody inserts something in these tables, you have to update your materialized view. Right? It's kind of like a cache. That goes into a little bit of cache theory and how to make sure that you always have the very latest cache, right? And you do update only those records that you need, right? So that you have always the latest cache. Make sense? So materialized views, really cool. Again, not for free. You have to actually implement these kinds of things. And again, you would use stored procedures to do this.